So the second example then, dy by dx equals x over e to the y. We can use separation of variables because they're divided. So separate the variables. What do you think we do? So times both sides by dx, dy equals x over e to the y dy, dx, I've done it again, dx. Not separated the variables quite yet, so what do we do now? Right, and then times both sides by ey, and we get e to the y dy equals x dx. So I've separated the variables. And now I integrate both sides. I integrate e to the y with respect to y, and I integrate x with respect to x. Just e to the y, isn't it? Yeah, because the number in front of it is just a 1, so that's just e to the y equals x squared over 2 plus c. Yeah. Okay? And so now that's the implicit form of the solution because it's solved, but we've not got it saying y equals something. So this is the implicit form of the function. What we do now is try and get y. So take the natural log of both sides, right, Daniel? So we say that in the natural log of the left-hand side cancels out the e to the power. So we're left with just y equals the natural log of x squared over 2 plus c. Take the natural log of both sides. Well, we can think of it, but the next step would be, of course, to say this could equal the natural log of x squared over 2 plus the natural log of c. We can separate it out, yeah. And so we've solved it. We've got a function now that describes the solution to that equation. We've done it by separating the variables in the recording. This is the graph of the solution to the differential equation that we've just plotted, look. This one here. Y equals log x squared over 2 plus log c, or this one here. This function is being plotted. And we can see weird things happen as when we get to 0. When x equals 0, it looks as though it's tending to infinity, negative infinity. And so, do you remember I said at the beginning, we have to define when this model, when these solutions apply and when they don't. So we have to conclude that as y tends towards negative infinity, as x tends towards 0, we need to specify that this solution is true for values where x is not equal to 0. So we would say in our final solution, going back to this page, y equals log x squared over 2 plus log c, so long as x is not equal to 0, to stipulate that in fact this thing goes all wrong when x is equal to 0, okay? Because you can't have the natural log of 0 effectively. No, you wouldn't necessarily know unless you realise that the natural log of 0 is undefinable. If you type the natural log of 0 into your calculator, you'll see that it won't do it. Okay? Yeah, you get a math error.